All right, hi everyone. A little different today because I'm not in the room. So this lesson, go to page 513 in your book, follow along. And when we get to the homework parts of it, pause the video, try to do it on your own, and then check back in the video to actually check your work. So I'm going to be talking a little faster because I know you can pause. You can slow me down if you want to, or you can fast forward if this is easy and you just want to check your work. You've already done it, then do that. So you should be on page 513. Hopefully you brought headphones today. If not, be respectful of those around you. Okay, so let me get my pen here. What do these graphs tell you about typical data values? Okay, so like right here, typical, like we would say that between, I don't know, right here, the between Q1 and 5.5, right? That range, that interquartile range from about 3.25 to 5.5. That's what typically happens. But really, our median is really the most typical. So our median of about 4.5. That's what usually happens. And so here, I think even the first time we looked at this data, we said right around 4, right around 5 is what's mostly happening, right? Where's the center at? So this tells us that reaction times are usually roughly 4.5 seconds. Okay. And someone read this, looked at this data and said it takes a person about 8 seconds to react to a change in driving environment while writing a text message. Okay, so this data right here suggests otherwise. Do I agree with the statement? No, because the data suggests that it is around 4.4 or 4.5 seconds. The data suggests saying because the median is there. Okay. The median being the physical middle of the data. I don't think that read that much. Let's move on. All right. So we've calculated the median. Now we're going to compute the mean. Now, how do you compute the mean? The mean is all these numbers added up. All these numbers added up. Mean is just another way of saying average. Okay. And to find the average, we're going to take the sum of all these numbers, right? We're going to add them all up and then divide by the number of entries, call it this time. Okay, so I can see that there are 20 pieces of data here. So what am I going to divide by 20? So I'm grabbing my calculator. We pause it so you guys don't have to I'll just do it here. 5 plus 2.1 plus 4.7 plus 2.8 plus 2.2 plus 3.3 plus 6.9 plus 3.6 plus 5.3 plus 5.6 plus 7.6 plus 4 plus 5.5 plus 8 plus 3.1 plus 3 plus 4.4 plus 6.3 plus 4.5 plus 4.2. So when you add those all up, you should get 92.1. Double check with someone around you. It's very easy to make a tiny mistake there. So double check when you add all those up. It should be 92.1. Divide that number by 20. And that is your mean, your average, 4.605. Okay. The mean and the median are pretty close. So what do I notice about the mean and the median? They're pretty close to each other. Pretty close. the average is slightly higher. And I'm going to guess it's probably because of that number 8. That number 8 is a little more, right? So the average is going to get pulled to the plus side a little more than the median will. What is an outlier in a set of data? So that 8. An outlier in a set of data is if something's extremely low or extremely high compared to what's going on. So the outlier here would be 8 because it's a lot higher than its closest counterpart, right? Whereas everything's kind of bunched together, 8 has a big spread to it. And the outlier, it's going to impact the average more than the mean. Sorry, more than the median. So that average got pulled a little higher, not much higher. 4.605 isn't that much higher than 4.45, but it got pulled a little higher than the other data. All right, compute the median and median for the data after you add an outlier of 20. So now we have 21 sets of data. And let's look at how does the median compare to the median of the data before the outlier was added. Okay, so right now we're comparing 4.45 with 4.605. And we said 8 might be a little bit of an outlier, getting that average a little higher. But let's see what happens if we take that 92.1 and add 20 to it. So 92.1 plus 20. Now we have 112.1, and now we have 21 pieces of data. So our new mean, our new average, when we put that outlier in there, is 5.33. And that's quite a bit, right? So it's gotten pulled pretty high, whereas the median is not going to be impacted as much. Like 4.45 was in between when we put these numbers in order, right? We had 4.4 in the middle from our previous lesson. 4.4 was in the middle, and 4.5 was on the other side, right? So we took the middle of them and we said, okay, 4.45 is the median. Well, now that we have 21 pieces of data, we would just go one to the right and we would take 4.5. So that's our new median. So the median went from 4.45 up to 4.5. So not impacted very much by the outlier. Now let's look at what happened with the mean. The mean went from 4.6 all the way up to 5.33. So what we can conclude here is that the average or the mean is impacted heavily by outliers, or at least more so than the median. Okay. Now, when we have distributed data like this, where it looks the best measure of center, it really doesn't matter what you use when it's balanced data right here. So we have a balance. This data is balanced. So you can use mean, you can use median, you can use anything, but mean, median, they're all going to be pretty much the same, but you can use the mean in this case because it's balanced data. Right? Now this data is skewed. When data is skewed, you want to use median because it's not going to be impacted by those outliers. Right here, we have an outlier, right? This outlier is skewing the data. So it's again skewed. So we are going to use median. Here, the data is pretty balanced. So you could use mean or median. Okay. So first, create a graphical display of the data. Use this representation. Decide which measure of center would be the best to report and calculate that measure. Explain. Study time data. Was this before? Sorry, just finding some stuff. Graphical display of the data. Using this representation, decide which measure of center would be the best measure of center. Report and calculate that measure. Explain. All right, let's try a box and whisker plot. So let's do a minimum, a quartile 1, a median, quartile 3, and a max. Now, if you decide to do a dot plot or a histogram, that's up to you. I'm choosing to do a box plot. All right, so what's my lowest? We got to put these numbers in order. I wish they came in order. That's always the biggest pain in the butt is putting these in order. All right, so 0 is my lowest number. That's also my minimum. All right, 0, just mark them off as I go. Anything greater than anything with decimals. Got 0.5. More with a 0 on it? No. Anything with a 1? We got 1.5, but there's a 1.0. That's our lowest one. All right, we got a 1. There's also another 1. Okay. That's all of them. Go to the 1.5. So that's the only, we got 1, 2 of those. 5. Anything 2s? Any more 1s? All right, 2. We got 2.0. 2.0s. 2. So we got 3 of those. Any 2.5s? Yes. 2.5. Another 2.5. Another 2.5. All right, we got any 3.0s? Yep. 3. 3. 3.5s. 1. About halfway through doing this data makes me wish I would have done a dot plot. Oh, I missed a 3.0, so make sure insert it in there. That's what stinks when you do this and you miss just one number, throws off everything. 3.5, 1 3.5, 2 3.5s, 3 3.5s. And then we have a 4. And then, of course, I run out of room. That column's done. Got another 4. 4.5 and a 5. Oh, man. Wish I wouldn't have run out of room here. 4.5 and a 5. Cool. And we have 5, 22 pieces of data. All right, my maximum now. Now I can fill this in though. Maximum is 5. I have 22 pieces of data. So I can split the difference, which is 11. So count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my median is going to be, I have 11 on each side. So in between this 2.5 and 2.5, so that's another 2.5. My quartile 1 has 11 on this side, so it's going to, if I split 11, 1, 2, 3, 4, 5.5. This next one would be my 5.5 because there's 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5. 5 to the left, 5 to the right. All right, so there's my Q1, which is 1.5. My Q3 is 1, 2, 3, 4. 0.5. Double check. 1, 2, 3, 4. Oh, wait, 1, 2, 3, 4, 5. Okay, and 3.5. All right, all that to say, now I can make my, if I have 0, 0, 5, 1, 1.5, 2. And the next one is 5. Well, Q1 is at 1.5. Draw that line. My median is at 2.5. My quartile 3 is at 3.5. Make my box and whisker. All right, how would you estimate the overall mean number of hours spent average for students in the United States? So the mean, my median is 2.5. I would estimate that my median or that my mean is going to be somewhere near 2.5 because this is balanced data. So balanced. And so my mean, I am going to guess, should be about the same, should be close to 2.5 as well. And let's calculate it. Once I calculate the mean, I can pretty much confirm this. 2 plus 2.5 is 4.5 plus 1 plus 0.5 plus 5 plus 1 plus 3 plus 3.5 plus 1.5 plus 1 plus 3.5 plus 2.5 plus 3 plus 4 plus 2.5 plus 0. Yes, you have to put the zeros in there. Plus 4 plus 2 plus 2. 56. Divide by 22. And like we thought. So your mean ended up being 2.54. Pretty close to the median. Okay. What are we looking at? What time? Let me pause here and come back. Okay, so with this homework, there's some creativity that you have to put in, like you have to put in the data set and see, try to create a median and mean that matches the description here. So on Monday, when I'm back, we will double check that, see who was able to do it, but please refer to those notes before and give this homework a try, and I will see you on Monday. Bye, everyone.